All right, let's talk about the language of chance. You know, probability isn't just some dry, boring math topic. It's actually this incredible tool, a language really, that helps us make sense of all the uncertainty out there. And trust me, it can lead to some conclusions that will absolutely blow your mind.
So, let me kick things off with a little puzzle for you. How many people do you think need to be in a room for there to be a 50-50 shot, a coin flip chance, that at least two of them share the exact same birthday? Go on, get a number in your head. Just hang on to it for a bit, because we are definitely coming back to this, and I'm pretty sure the answer is not what you think.
Okay, so before we could even begin to calculate the odds of anything, we have to do something really basic but super important. We've got to lay out the entire playing field. I mean, we need to map out every single possible thing that could happen, no exceptions.
And in the world of probability, this playing field has a name. It's called the sample space. We usually just write it as a capital S. Really, all it is the master list of every single possible outcome. It's the foundation for everything we're about to do. Let's make this real. Imagine a super simple experiment. We're just going to toss two dice, okay? So what could happen? Well, you could get a 1 and a 1, or a 1 and a 2, a 1 and a 3. You get the idea. All the way up to a 6 and a 6. If you list out every single one of those combinations, you get exactly 36 possible outcomes. That's it. That's our sample space.
Now let's be honest. We're usually not interested in all 36 outcomes, right? We care about something specific happening. Maybe we're betting on a certain number. Well, that specific thing we're interested in is called an event. Think of it like taking a slice of that bigger sample space pie. It's the one outcome, or maybe a few outcomes, that we've got our eye on.
So, back to our dice. Let's say our event, the thing we care about, is rolling a total of 7. So what do? We just go back to our big list of 36 outcomes and we pull out every single pair that adds up to 7. You know, a 1 and a 6, a 2 and a 5, a 3 and a 4, and so on. When you do that, you find there are exactly 6 ways to do it. That little collection of 6 outcomes is our event. Okay, so just to recap, we've got our map of everything that can happen, the sample space, and we've got this specific thing we're hoping for, the event. So, how do we actually connect those two to find the probability? Well, it's kind of amazing, but this whole language of chance is built on just 3 super simple common sense rules. That's it. All right, rule number 1. A probability is always a number between 0 and 1. 0 means, no way, not going to happen. 1 means, it's a sure thing, absolutely certain. Easy enough, right? Rule 2. The probability of the whole sample space is 1. This is just a fancy way of saying, well, something has to happen from our list of possibilities. And rule 3. If 2 events can't happen at the same time, like you can't roll a 5 and a 6 on one die, you can just add their individual probabilities together. And believe it or not, these 3 simple ideas are the bedrock for all of probability. Let's just double-click on that second rule for a second. A probability of 1. That means absolute certainty. It's guaranteed. So when we roll our 2 dice, there is a 100% chance, a probability of 1, that the result will be one of those 36 combinations we listed out. I mean, it has to be, right? And then you have the other end of the spectrum, a probability of 0. That's for something that's flat out impossible, a null event. So what's the probability of rolling a 13 with 2 normal dice? It's 0. Why? Simple. Rolling a 13 isn't on our list of 36 possible outcomes. It's not in the sample space, so it can't happen. All right, we've got the building blocks, sample space, event, and the 3 big rules. So now let's actually put them to work and figure out the odds of rolling that 7.
And the math here is actually super simple. All we do is take the number of ways our event can happen. Remember, there were 6 ways to roll a 7, and we divide that by the total number of things that could possibly happen, which was 36. So 6 divided by 36, that simplifies down to 1 over 6. There's a 1 in 6 chance of rolling a 7. See, it all just flows logically from those basic ideas.
Okay, so now we know the rules of the game, we've got the tools, so it's time to go back to that birthday question I asked at the beginning, because this is where things get really interesting. This is where we see how these totally logical, simple rules can lead to an answer that just doesn't feel right.
So let's try it again. How many people do you need in a room to get a 50-50 shot at a shared birthday? Now that you've seen a little bit of how this works, what do you think? Still sticking with your first guess?
The answer is 23. Just 23 people. That's all it takes. Seriously. In a room with only 23 people, it's a better than 50-50 bet that at least 2 of them have the same birthday. I know, it sounds way too low, right? But the math, using the exact same rules we just talked about, is rock solid.
So what's going on here? Why does our intuition fail us so badly? Well, it's because we instinctively think about the odds of someone matching our birthday. But that's not the question. The question is about any pair of people in the room matching. And the number of pairs just explodes as you add more people. With 23 people, you're not just making 22 comparisons, no, you're making a whopping 253 different comparisons between pairs of people. And with that many lottery tickets, your chances of hitting a jackpot, a match, go up way, way faster than we think.
This is really cool, right? But probability is so much more than just mind-bending puzzles or figuring out odds at a casino. It's a whole way of thinking. It's a tool we can use for pretty much everything, to be more precise about what we mean when we say we're not sure.
There's this great quote I came across that really nails it. It says, probability can be seen as a measure of the individual's degree of belief. Think about that. When a weather forecaster says there's an 80% chance of rain, what do they mean? They don't mean it's going to rain on 80% of your neighborhood. No, they're expressing how confident they are based on all the data they have. They're putting a number on their belief.
And that really brings us to the big takeaway here. Once you start speaking this language of chance, you realize that very few things in life are a hard 0 or a hard 1. Most of what we deal with every single day lives somewhere in between. So I'll just leave you with this question to chew on. What are some of the things in your life that you treat as total certainties that are really just very, very high probabilities? And if you start to see them that way, does it change anything?